class. Okay. I did send the URL for doing the exam quiz basically, but you can do the quiz as many as you like. This is the URL. Okay, I will post it in the what's that? The chat box. Where is the chat box? Okay, so this is the URL. Did I think I have to share the where is the present now? Entire screen share. Okay, so I already set up the quiz in our server opencourse.itts.ac.id. The course number is 104. Make sure the course number is 104, and the enrollment key is I posted in email already, but I repost again in chat box. So this is the okay. So that's the enrollment key, ITTS PU 2023. Okay, so that's the enrollment key. The above is the URL, and you will see something like this. Okay, I try to add all the material here, but I don't have time. Too short. So I just set up the quiz. So this is the quiz. Make sure you can access the quiz. It will look like something like this. If you can access this, I already attempt a quiz several times. It will limit your time to 4 hours. The quiz, it has around 100 questions. You can do it multiple times, many times, as many as you like. The quiz will be something like this. Okay. Okay. The answer is false. Okay. You can answer. Actually, most of the materials for the quiz you can see it in my wiki. This is my wiki. OnnoCenter.or.id/wiki, and you can type orange here. So all the materials for the quiz is actually here. You can search here. Okay, but the quiz is very tricky, so make sure you read carefully the questions. That's it. You are welcome to do the exam as many times as you like. Make sure you reach above 90. Okay, it has about 100 questions, so make sure at least 90 questions is correct. It's not that difficult, but it's time consuming basically. Okay, so you can put something like this, and then cross validation. Okay, this is the here. Okay, confusion matrix. See, okay, so we can see, and it has multiple choice as well, but you can see the multiple choice is very crazy. We have how many choices here? So it's a bit crazy like this. So feel free to do the exam as many times as you like. Make sure you have 90 questions correct at least. Okay, so this is my part of the exam. The other part will be Professor Wiranto exam. Not mine. Okay, if you have any questions, put it in the chat box. So I hope you can access the quiz. Previously, I think yesterday, or last night, I forgot. I made some mistakes. So the question bank is not correctly linked to the quiz. So I have to delete the old quiz and create a new quiz, something like this. Okay, that's it. Okay, that's the quiz. Okay, okay. Now, if you have any questions, put it in the. I still cannot record this class even I'm co-host. Okay, I have no idea. I record the class. I'm not using the built-in recording facility in Google Meeting. So I use OBS for recording the screen. So I try to record. I hope I record correctly. The first class, I failed in the first class. The second class is okay. I upload to YouTube. I try to record for this one. You are welcome to record the class, and you are welcome to upload the class to YouTube or whatever. Okay, okay. So for today, this is the class for today. Can I make it bigger? Preference, font. Oops, sorry. Okay. We have learned supervised learning last week, so we will learn unsupervised learning this week, today. But I may skip or jump to other material from time to time, depending on the condition. Okay, so I may jump again to supervised learning. I may jump to forecasting, to make things more clearer for you guys. Okay, now I already made some example on clustering and supervised learning, but I will redo the example very quickly. Okay, oops, wrong. Okay, for unsupervised learning, the easiest way to do unsupervised learning is using this example, using image analysis. I can import some image, domestic animal. I can see the animal. So I think this one is the in our first meeting. I will redo very quickly. So hopefully you will remember what happened. So here I can view. I grab the image viewer widget and connect the import image to image viewer widget, and we can see what kind of image I have from the file. So this is the image we have. There is no label on this image. There is image file name. That's it. But this is not label. So our task is to classify the image. Whether so basically we create a cluster from the pictures. We can see from this image these two, goose and rooster, are may likely same cluster. This one, goat and horse, may be in the same cluster. Calf and ox may be in the same cluster. Calf, ox, cow, same cluster. Hen, turkey, duck may be in the same cluster because they are same birds family. So as human, we can do something like this. As computer, it cannot do something like that because the data is very simple. The data is only this one. So we have only name of file, file name, size, and picture pixel. So we need to extract the feature of the pictures. So we need to extract the feature. Features mean how many legs it has, how many wings, Does it walk on 2 feet or 4 feet? Does it has 2 eyes? That kind of thing. So that's feature. So basically, we will extract the feature using neural network. The neural network we are using is, I will use, oops, sorry, image embedding for the neural network we are using. So this is Google Inception version 3. Okay, it's a neural network. We can check using this one, Google Inception version 3. So this is the neural network we have. Neural network, basically we can view a neural network, we can see a neural network as linear regression, but to be able to what, model a non-linear things, then we can network. So basically, we can see this as a linear regression process. So we can see, so this is the neural network. We can see A times W1. W is when we have AX plus B equal to Y, this is the gradient of the linear equation. So W is the gradient, but we have many X here, and we sum all the X times W. We have activation function. This is for basically for handling non-linearity in the data. Okay, so the activation function is for handling the non-linearity in the data. In the normal linear regression, we can see this as B. Okay, so we have W, X plus B is equal to Y. But in nonlinear equation, the activation function may be something like this. Activation function. So we have many type of activation function. We have ReLU, hyperbolic tangent, sigmoid, leaky ReLU, max out, ELU, whatever. So this is basically non-linear. If it is linear, the line will be straight. Whether the X is minus, X is plus, it will be straight. But in non-linear situation, we can see this is non-linear, this is non-linear, this is non-linear, this is non-linear. These two is quite good for classification. This 3 is sort of good for linear regression, something like this. So each activation function is good for certain purposes. But my suggestion is try and error for different type of data. Then we will have some feelings which one is good for what. Okay, now back to this. So sorry, so we will do the Google Inception process in orange. Oops. Okay, so we send the data, the image to image embedding, and we can see clearly the original data is this. This is the original data. The data after the image embedding, we can see it will add N0, N1, N2, N3. These are the features extracted using Google Inception version 3. Okay, so the feature is not how many leg, how many wings, how many eyes, whether it is thin or fat. So it's not that kind of feature. So basically it's numbers like this. Our task for unsupervised learning, basically trying to cluster certain feature into certain cluster. For example, if we see in this, okay, these two. This is 0.35, this is 0.36. This is quite close. This is 0.34. This is 0.30, 0.33. So we have cow, kids, we have horse, we have, okay, horse, we have goat. So 0.3 something seems to be have 4 legs. From the second feature, we basically do the same thing, but basically the algorithm will try to optimize the classification, the groupings among 2000 something feature extracted using Google embedding. Okay, whoops. So this is 2000 something. This is only 1000 something. So at the end it's 2000 something. Let me see. So this is 2047. Actually 2048 because it start from 0. If we start from 1, so the total feature is 2048. So we need to do clustering from 2000 something feature using this one, distance. Okay. Okay, using distance we can make a cluster. We can, so basically the actual, I will remove this one. Okay. The program, the machine learning program is basically very simple. So we have input data and we have computing process. This is image embedding and distance. These two are computing process. And then we have visualization. Basically, these 3 process. That's it. Okay. To make things easier to see, we'll add image viewer as well. So this part is visualization, this part is computing, this part is data gathering, sensor, whatever. So this part is for sensor, compute, visualize. That's it. That's the programming of AI, machine learning, data analysis is as simple as this. After we we optimize the distance among the features, then we can see the cluster. This is the cluster we see, and to visualize the cluster we can see image viewer, we can see both simultaneously. Okay, now we can see very easy these two very similar, these two very similar, these two very similar, these 4 very similar, these two actually small, these 2 are big. So computer is dumb, it's not smart, so it doesn't know that lamb, sheep is small, calf and cow are much bigger than lamb and sheep, but from the picture seems to be similar. Actually it's not similar. Okay. But it's all have 4 legs, or white. There's some black here. Okay, these 2, and then we can see here all 4 legs. This one, okay, it mixed between. Basically, all of them are cute. So basically, this is wrong cluster. This is cute cluster. Whatever. And then we have bird cluster. So we basically have 3 cluster: cute, bird, and 4 legs. That's it. Hey, where is the lamb and so on? The horse. Oh, Okay, we have horse here. So we have the big cluster, and this is the thin cluster. So we can have something. So, okay, now we can do the same thing. So this is unsupervised learning. Basically, we are not labeling the data. Orange or the program is trying to cluster based on the feature we have. Okay. Now I will change the program little bit. I will remove this too. Remove this one. So the important part of the unsupervised learning is these two. This is the actual program, and this one is for visualizing. The visualization is using hierarchical clustering, and this is the actual program. Now I will read different data. Let me see. Orange. Okay. Let me see if I have. I'm not sure if I have shown you about this one. I forgot. So I create sample data. This is the income, level of education, time of education, how many years of education, how many house they have, how many motorcycle, car, children, credit, bank credit, name, and then classification. I already made some classification here manually, or we can change the classification somewhere here. Maybe I can change into sejahtera. Okay, so this is manual. We can check if the manual classification and the automatic classification, is it the same or not the same. Okay, so we have stunting, we have classification. These two are labeled by us, by human. Okay, stunting and classification labeled by human, and then we are trying to check whether this data will correlate with our classification. Okay, how can we do that? It's very simple actually. So this is actually the feature. This is feature, income, education, number of house, number of motorcycle, car, kids, bank loan are feature. Name is basically metadata, and then classification and stunting basically label. Okay, so the data is already labeled, but we can check, is the label from us, from human, and label from machine, is it the same or not the same. So our task is basically trying to compare whether our label same or not the same between human and machine. And I already changed one label here. Okay, it should be sangat miskin. I changed it into sejahtera, which is actually wrong. But anyway, we can check what happened. I will save. So the file name is miskin.xls. I will read the file name using orange file. Okay, this is miskin. Open. Okay, reload. Okay, we can see the data using data table and connect these two, and you can see this is our data. The data says it has 10 features, so income, education, house, motorcycle, car, kids, loan, classification, stunting, considered to be feature. Actually, in our mind, classification and stunting are not feature. Okay, classification and stunting is our target. Okay, here it says no target variable. Okay, and it notice there is one meta attribute which is name. So name is the meta attribute, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 feature, 30 something instance. Okay, with no missing data. Okay, so this is our data. But we need to change the data because we want to use classification as our target. But we will play around with unsupervised learning. So this is we change into okay, we will analyze unsupervised learning. Basically, we want to compare between human classification and computer classification. This is very important. For example, in Ministry Pak Teten Mas Duki, what ministry is he? I forgot. Teten Mas Duki. Okay. So he's the Ministry of Small Medium Enterprises in Indonesia. So Teten Mas Duki. So I was in his office last month or 2 months ago. I forgot. Basically, they have 13 million small medium enterprise data. 13 million, and the number of feature, I forgot. They have huge number of feature, a lot. I think 100 of feature for each data. So they have 100 of features and 13 million data. The problem is when they label the data, they will label it manually. For example, a company with like 1 million rupiah of fund, it's considered maybe micro enterprise, something like that. So basically, they have if then algorithm for classifying the companies. In our approach, the classification process is much more smarter than if then approach. So their approach is still if then right now. Okay, so I will show you what happened. Oops, wrong. Okay, so this classification is using if then. We will try to use the computer, the algorithm, the distance widget to check the classification. To do this, I think we need to transform first because is incorrectly signed. There is no target here, and incorrectly sign classification and stunting as a feature. So the classification and stunting, I want to use it as a target basically. So what we can do, we can transform, we can change the data, we can select the column, and then we move here and we select column. So there is no target here. I will, so one metadata, classification, stunting, ignore these two. I like to use classification as target. See what happened. Okay, using the data, our data. So okay, when we connect the output of select column to distance, then we can check the hierarchical clustering here. Okay, can we zoom in? Okay, oops, Okay. Okay. Now, so the color is based on classification. So it's that's becoming very easy for us. Which one is misclassification? Okay, we can see this one. This will likely misclassification. This one misclassification. This one misclassification. So we have at least three misclassification. So as a label, we use name. We can change the label into classification. So we can see this is the yellow is most likely sejahtera. One is wrong here. Okay. Uh, this blue dots is miskin. One is sangat miskin. So one is wrong. So several is wrong here. Okay. So our label by human, so we can see the label from human. We have one wrong, one, two, something like. So we can see which one is wrong, and then basically what we can do after this, we will wait, where is the file? We can make correction to the original file. Okay, this is the one. So this is what happened when we do the analysis. Oops, sorry. Okay, to make things easier, how can I make it easier? So the annotation I use name is easier. So I think Rani is wrong. Rani. Here, where is Rani? This one. Rani is wrong. Rani should be sejahtera. So here, miskin. So we have to change Rani into sejahtera here to make it. If we believe in the computer calculation, okay. So that's how we do the correction like that. Okay. So that's if the target is classification. Okay, so we can see we have three groups here. One group, second group, third group. Okay, so that's how we group these things. It's very clear. Okay, this is from the computer. So people and computer can be different. Now, if we do the labeling for stunting, okay. By the way, we can only have one target because the algorithm is not smart enough. It cannot differentiate if we have if we use two targets. So we maximum have one target. That's the easiest way to analyze things. Okay. So if we have several targets, we need to analyze one by one. We cannot analyze simultaneously. It's tough. It's difficult. So it's easier to analyze things one by one. One target, another target. Okay. So for example, we want to analyze stunting rather than classification, then we can see after distance, we can see we annotate using stunting. See, stunting is more random. Stunting is not random, so it's more difficult to analyze. So some from this group have stunting, some from have stunting. So basically, Oh, by the way, my data is not correct. Basically, I just create random data, so my data may be wrong. But basically, in my data, the stunting has no what's that? There's no correct model. So, but basically, using the this feature, then we can classify. If the data is correct, then hopefully we can see a certain feature or certain things make something more explicitly visualize. When we visualize stunting, it can be explicit, but because my data is just random data, so it's becoming like this. Okay, so we can see one thing from another using a very simple method like this. Just changing the target, then we can see things differently. Or we can see things differently as well using this one. For example, this is our target. Okay. Then, oops, sorry. See if we can see. So, can I? Oops. Oh, okay. So we can see in this group the income is small. This part is have small income. This group a little bit higher income. This group it's much higher. This group is 191719 something. This group is 556160. This one the digit it's much smaller. So basically we have three different groups. Okay, that's from the income. So when we analyze things, it's very easy like this. So we can change the which what kind of thing we want to analyze. We can see using these things. Okay, just change. So for example, we want to analyze other things. For example, what? This one. How many loan we have? Okay, so we can play around with this. Okay, oops. Oh, this is penghasilan. Loan. See, this part have some loans. The other have no loans basically. So only these guys actually uh, uh, get some money from the bank, loan from the bank. So that's how we analyze things. Using this kind of techniques, then we can publish paper. Okay, so we analyze things and we publish paper. I already sent the paper to you guys. This is more brutal actually, the paper. I think I show you. I will review my paper a little bit. Okay, this paper is basically comparing between human and machine. The data I'm using is what, 11 or 12 years of data. So the data collection process takes long time, very very long time, because Satu Indonesia Award has been running for what, 13, 14 years now. And this paper is 2021, so they have been collecting the data for more than 10 years, I think around 11 years at that time. So we have a lot of data, big data. The data is big. The data is collected by here, Tempo Data and Analysis Center. So Tempo actually the one who collecting the data, and then I asked Tempo, can I access the data? And then Tempo give me access to the data, but Tempo needs 6 months to pre-processing the data. So the pre-processing process takes long time. Don't worry. So having said that, if you like to do some research on data analysis, better you have big data, lots of data, and you have to spend long time for pre-processing data actually. Okay, so Tempo spent 6 months. Okay, here, 10 years. The data is 10 years, and Tempo processing the data for 6 months. Okay, and then I do the programming for what, one day, I think, and run the program for 30 minutes. That's it. and, and I get the results using 30 minutes only. So they have to spend like 6 months. They collect the data for 10 years and process the data for 6 months. We, the programmer, do the programming for one day, 2 days, and run the program for 30 minutes and get the results. When I start going to publish the data, I asked friends from Tempo or Astra, would you like to have your name here? They don't say, they said no, that's okay, thank you. Well, okay. I put my my name only. So this is I'm doing for fun only. See. So this is for fun, and this is Scopus. I think Q third quarter the third quarter. Yes, something like that. So it's it's not really serious. But basically, what I want to show you is in a journal paper, we can put our source code. I think the reviewer doesn't, they don't know that I'm putting the source code here. Okay, so this is the source code I put here. This is how to create the model. Basically, I'm testing which algorithm is good for analyzing the model. Basically, I found random forest is the best, and then creating the model. So basically, corpus is for grabbing the text, because all the information in text, and then pre-process. Back of words basically vector database. Basically, it transform a text into what coordinate, basically like that. So a text, we transform a text into coordinate, and we save the whole thing in. If you read in the other journal paper, they use the word vector database. Basically, we change the text into vector. Okay, and then we analyze using random forest and save the data. That's it. Having the data saved, so we have the saved data, so then we can predict the next candidate for the Satu Indonesia Award. And then so we already have the data from 10 years, and then the next candidate we analyze, and we use prediction to predict and save the data. We as jury, basically we measure the motivation, obstacle, outcome, outreach, and sustainable of all the nominee of the Satu Indonesia Award, and then we can decide which one should receive the award based on this mark: motivation, obstacle, outcome, outreach, and sustainable. And then this is the workflow to compare between the outcome of the jury, human, and computer. This is basically to to compare. Okay, and then this is the where is the results? Okay, this is the results when we compare. Basically, when we compare these two results, it's not that difference between human and machine, basically. Okay, that's it. I have to thank PT Astra International and Tempo. Okay, but this is for fun. This is not really serious. Okay, that's it. Okay, so you can use the orange to do these things, but I have not show you how to analyze text. This is only tables. Okay, let me see. So this is based on tables. Okay, now let me see. Is there any question so far? For last week, was there any? Oops. I don't know about the any pin. I don't know the Ariantika, so I don't know. I don't know the answer. Uh, so maybe later Pak Wiranto will tell you about the pin stuff. Oh, okay. So the pin will be okay. Pak Wiranto already put the pin here, 3386. Okay, so you can fill your attendance because I don't know the pin. Sir, I have question. If there is some misclassification, what should we do about it? What is the pre-processing step that makes? Oh, what is the pre-processing steps that takes 6 months? Okay, for my data, the Satu Indonesia Award data, why it takes 6 months? The problem, look, the data is collected in 10 years period. The problem with 10 years period, the person who handle the data is different for every 2 years, I guess. They change the person responsible for the data collection. The problem with that is every single person will use their own style for collecting the data. That's problem. Okay, if the data collected using different style, so we need to what's that? We need to make it into same, make all the data into same column, same style. Otherwise, it's difficult for us to analyze if each single data use different style. So that's and we have what each year, every single year, we have about 20,000 nomination. So imagine we have 20,000 and we have 10 years. That's when we have around what 200,000 data. That amount of data is very difficult to collect in Excel file. So Tempo nearly give up when I asked the data make it into single same format because so that's the problem. Okay. Now, if there is some misclassification, what should we do about it? It's depend on us actually. We can ignore. We can mean what I mean with ignore. We can what? We can allow some misclassification, okay, or we can remove the data. But to be honest, if possible, do not remove the data because sometimes it makes if the data is too good, then our model will likely to be overfit. That's a problem. If the model overfit, it will not allow any what, wrong data, something like that. So for example, like this, I will make, I will create some data, new data. What is overfitting? Okay. For example, I have maybe I will create a weather data, time, humidity, and then weather. For example, I have temperature 25, humidity 30, weather hot. Okay. 24, humidity 25, weather hot. For example, we have 13, humidity 90, rain. Okay. So we can write down something like this. And then if there is a misfit, for example, like this. We have 25, but humidity is 90. Then we can decide rain or hot. For example, it's rain. So this becoming the main, what's that? Main data. This becoming the outliers of the statistics. So we need to allow some outliers so the data will not overfit. Okay, if the data overfit, it will not allow for different uh, different values basically. Okay, let me give you some other example. This one is Satu Indonesia Award. Satu Indonesia Award. So Satu Indonesia Award is supported by Astra International. So this is the jury. Okay, I like one jury. This one. Why? Most of us, most of the jury will take very safe marking. For example, if this guy is bad, sometimes I give 7. If this guy is good, I give 9. Okay, so most of the jury will give that kind of number, except Dian Sastro. Dian Sastro is more brutal. When she give mark, she will give. If it is bad, she will give 1. Many of us give 5 or 7. She give 1. So her mark will likely to be outliers among the other jury. Okay, but this outliers is very important from my modeling point of view. If I want to evaluate a certain all of the candidate, if they can pass Dian Sastro, that means he or she will likely very good. Okay, so I use Dian Sastro marking separately from the others. So otherwise the model will overfit into 7. Everything will give 7. But if I have Dian Sastro, the marking will be varied between 1 or 9. So this is good. Okay, so overfitting is not good. Most of the jury will be overfit into 7. So I don't like the other, most of us mark, but I like this one. So this is the recipient of the Satu Indonesia Award. Okay, that's answer the questions misclassification. So misclassification is okay. Okay, what is the difference between orange and tableau? Okay. From license point of view, Orange is open source. Tableau, I think you need to pay something. I don't know. But from my knowledge, the easiest way to answer this kind of question, we can use Gemini. But to answer quickly, I think Tableau is more aiming for visualization. Yes, it has some ability to do some calculation, but aiming for visualization. While Orange is more aiming for calculation. That's the major difference. Okay, I hope that's answer Pa Ahmad Iqbal questions. Okay, no, that's why I use Orange a lot. But my aim is for calculation. Now I will show you some miscalculation, how it's look like. The miscalculation. Where is my orange? Here. Okay, so we already understand something about the. So this is unsupervised learning. Okay, so the first example I use image. The second example I use numbers. Okay, but the coding is same coding. basically we use distance and hierarchical clustering. Let me use iris. Is there any iris here? Okay. Again, as usual. Okay, iris. How the data looks like. So this is the data. Okay, now this is classification problem. This is not linear regression problem. So for modeling these things, I can use tree or random forest, but I cannot use linear regression. Okay, I can use logistic regression. Okay, for example, I use logistic regression. Then I have the model, and then I can visualize the classification. Where's the it called? Oh, I think around here. Okay, this one. To see the misclassification, we can use confusion matrix here. Oops. Oops. Oh, doesn't like confusion matrix. I have to put it into nope. Okay. Let me see. Oh, okay, okay. Okay, I can use this one. I can evaluate several algorithm here. I have linear doesn't work here. Remove linear. I have logistic. I have random forest. I have tree. I have naive Bayes, for example. So I will evaluate 4 algorithm: tree, logistic regression, random forest, naive Bayes. So I will test this one. 4 algorithm I will test, and then we can check the precision. We can see tree is the most not the most precise. Logistic regression is the best, 96% precise. Tree only 94%, random forest 96, naive Bayes 87%. If you like to use neural network, I can grab neural network here. In the real world, you can use Keras or TensorFlow to do these things, neural network. Here I use, for to make things simpler, I will use single layer neuron, and then the activation I will use ReLU. Okay, or because this is classification, maybe I can use logistic. Okay, so you can play around with this. Okay, either you can use identity, logistic, hyperbolic tangent, ReLU, whatever. So you can play around with it. Because this is classification, I will use either logistic or this. The solver, the good solver normally Adam. Okay, the number of iterations 20 times. That's not good. 20 times. Too few. We need more. Anyway. Okay. Now, let's see. Neural network is not good. I changed the. Let me see. Okay. Let me see if I. Okay. See if I put the maximum number of iteration when you code the neural network. The variable name normally epoch. Okay, epoch is the maximal number of iteration. So I increase into 200. Okay, so it takes sometimes. See, it's getting better, 94%. So it's close to 3. Okay, if I use logistic, okay, so hyperbolic tangent is much better, 97 and 94. Logis is good, not as good. Relu is same. So we can use either hyperbolic tangent or Relu as activation function. Okay. Uh, if we use, for example, 50 nodes, we use double 50 and 50. Okay, well, not as good. For example, I use 3 layers, 50, 50, 50. What happened? She's getting better, 95. So that's the kind of effort we have to aim. So we are trying our best to have the most or of the the best precision. Okay, so we have the best one is logistic regression. The second best is random forest, then neural network. So that's how we make a competition among the algorithm. Okay, so because of this, to be honest, I'm not in favor of neural network because of this. So so neural network is good actually for image processing and stuff like that. But for numbers, the other algorithm can be much faster than neural network. Keras, TensorFlow. It's good for image, but for numbers, okay. Sometimes I prefer the other algorithm. It's much faster. Anyway, so I feed the output into confusion matrix. We can see how confused the algorithm. This is, we can evaluate the confusion level basically of each algorithm. 3, we have 4, we have 8 out of the, so the diagonal is the correct one. So the correct one is in diagonal. So this is predicted, this is the actual. So actual Iris Sentosa, predicted Iris Sentosa 50. Iris versicolor, predicted versicolor 46. 4 fail. Okay, 4 wrong. This one Virginica 46, 4 wrong. So this is the wrong one. And then, so we have 4 wrong in 3. In logistic regression, we have 5. Oh, sorry. In 3, we have 8. 4 times 4, 8. Logistic, we have 5, less. Random forest, we have 6 more. Naive bias, too many. Not a good algorithm for this. Neural network, we have 7. Okay, so this is how we evaluate certain algorithm. Of course, we can see clearly here that no single algorithm will be able to predict correctly 100%. It's very difficult. Okay, so we have to maximize using this. We have to allow some error. Okay, that's it. Okay, and then having said that, we can see there is we can select correct or we can select misclassification. When we select that, then we can plot actually. Where is the plot visualization? Here, scatter plot. Okay, we can fit, we can select misclassification. Sorry. Okay, this is the plot data. And then, okay. Okay. Okay, let's see. If it to make things more fun, I will send this here. Okay, that will be more fun. Uh, okay, let's see how it works. Okay, if I select misclassification, then we can see uh, this 4, 1, 2, 3, 4, 1, 2, 3, 4. This is the misclassified in 3. In logistic regression, this. In random forest, this. In naive Bayes, this. Oh, too many in naive Bayes. Neural network, this. So we can visualize which data is misclassified. Different algorithm, different misclassification, basically. Okay. Okay. So that's why we have to choose which one is our preference. Okay. If we have lots of data and it takes the calculation will take long time, so we have to choose the algorithm carefully because we need to be able to have the results as fast as possible, basically. So we need to optimize time and precision, basically. Okay, that's it. Okay, the color is iris. Okay, we can play around with this. Okay, wow. Oh, this is sepal length. Okay, any questions? Let me see. If this is from Muhammad Amri. Classification and data preparation. If I want to use a classification model, but the source is separate into multiple source table, do we need to create a relation between table first, or there is another method to detect relation between multiple source? Okay, I have to be honest with you guys. Uh, Most of the algorithm is not smart. They are dumb. To be honest, they are dumb. The algorithm is dumb. They are not smart. So when you see this, the input data, of course relation stuff like that is okay if we are doing coding for web, for we can do relation. But in this kind of work, it's where is the data is single file. That's the problem. Okay, single file, and we fit the single file into this algorithm. So basically, we need to have a single file, all the data single file. We fit to the algorithm. That's it. Okay, no relation, nothing. so so we need to generate the we have to dump the database, any relation whatever we have to dump into a single file, otherwise difficult. Okay, because most of the data mining, data science, data analytic, machine learning, they are dumb actually. They are not as good as you as smart as you think. So we need to help this program make the program not to do more. Of course, if you like, they have a feature to like this merge data. You can concate the data. You can select. If you do something fancy, it has something like this. But easier when I play around with this data, it's easier for us to have single file, big file, and process that file. How to generate the file? It's up to us. We can correlate. We can whatever. Okay, before the orange or before Python processing. Okay, easier for us. Otherwise, woo, it will be confusing when we do the programming here. Okay, Let me see other things. Okay, that's it, eh? Okay, let's let's continue. Now, where is orange? Okay, okay. Now I want to do more brutal. Oops. Okay. I'm going back to my Excel file. Okay, where is my file? Where is this one? Okay. Hey. Okay. I close this one. Don't save. Okay. So, so this is our original file. For example, we are a government body and we want to create a program for and this is happening actually. This is what happened with one of my student. This his this particular student is fourth year. It's not fourth year, fourth semester undergraduate. So he is fourth semester undergraduate. He get the data from Bapeda, the planning body of Tangerang Selatan City. Okay, the data from planning body from Tangerang Selatan City. He received the data something like more complex than this, basically, and it has classification. And then the aim is if I want to change classification for certain person to different classification, what should I do? What should we do as government? Should we increase the income? Should we increase the pendidikan, education, number of house, bicycle, car? Should we increase children or should we increase loan? To change the classification from miskin to sejahtera, from sejahtera to sangat miskin, whatever. So that's the objective. If we are the government, we need to change the classification. What should we do? Which one is the best? So what he did, he actually used the same data. He create the model first. So we can create the model from this data. And then, of course, we need to correct the classification using the data. And then we have the correct data. Then we have we have different file. So we have the second file. From the same file, we copy into second file. We change. For example, the first change, if we increase the income for certain amount of income. So we increase the income. What happened with the classification? How many people change from sangat miskin to miskin? If we change the income, if we change the education, what happened with this one? So we do some trial and error. So we have the model first, and we modify the input file. The second, so we copy into a second file. The second file we modify this one, either the income, education, number of house, number of motorcycle, car, kid, loan. Then we can see the change in classification. For every from the government point of view, they always have to think how much budget they have to allocate to do these changes. Okay, so having after doing some analysis like this, then they can decide, okay, if I change the income, we need to have certain amount of budget. If we need to change the education, we need to allocate certain amount of budget. So from this, after we analyze the budget, then we can decide which one is best. Okay, the most effective, most efficient program. If we have certain amount of budget, which one will have the most impact to the users. That's how we do it. So basically, I will draw the program first. Uh, what time is it? I'm not sure if I have enough time. So basically, so we have the file, okay, and then we do the modeling first. Where is the oh, we have to do this one, select column. I will read the real file, this one, miskin, and then we do select column, okay. I have to give it back here. For example, this classification here, okay. So the target is classification. Then we do the modeling. Model, where is the model? Model. For example, we use random forest. Then we have a model. The output of this one is the real model using this data. Okay. Now to do the prediction, what we normally do. So this is how we do the like decision support, data-driven decision support system. So when the government have to decide on something, they have to decide based on data. It's not based on witchcraft, something like that. So they will do some decision based on data. To do that, we have to fit the model. So the output of the random forest or any algorithm is model. We can fit the model into prediction widget. Okay. Now the prediction widget basically needs two input. One is the model, one is another file. Okay, so basically we need to read another file. We have to do the select column again, another file, and we fit the file. I will remove this connection. We fit the file here. Okay. See, the line is not straight line, it's dash line. That means there is no data yet. If I connect these two, the data will be read from this file. The problem is this is the same file. So this is miskin.xls. This one is miskin.xls. So I have to change the file first, okay, to create the actual data. Now, sorry, where is the my file? Okay, so this is the file. Okay, I will save the file. So this is quite easy to do because we have how many data? We have only 30 something. Oops, we have only 38 data here. In the actual work in Tangerang Selatan, for example, I think we analyze around couple thousand data, so it's more difficult because we have thousands of data. Okay, this one is only for example. So for example, we want to change this one, the income. So I will file, save as. Okay, I already have this file here. Let me read the file. I think I already changed something. Let me see if I can read. Open. Oops, sorry. Where is orange? Here, orange. Where is? Okay. Let me see. This, how many zeros here? 1, 2, 0, 6. Okay. Okay. Oops. Same. Oh. How many zero? 6. Oops. How many zero? Oh, this one is same. Oh, this one is 7. So I basically add 1 0 here. Okay. 1 0 in every income of every person. Oh, this is unfair, but just to show some uh, so this is unfair actually, but anyway. So how many zeros? 1 2 3 4 5. Oh, this is 2 0. 1 2 3 4 5 6 7. Okay, 1 0. So I add 1 0 at the end of the for every single income. I put 1 0 more. Okay, so let's see what happened if I put. So this is only 6. The other one is 7 0. Okay. Now, where is the file? Okay. I have to change this one. This one. Open. Reload. Let me see. So stunting is ignore. Classification becoming a target. Okay. So the file format is the same. Select column must be the same as well. Whoops, whoops, ups, crash. Oh, I have to remove first. Okay. Oh, see, this one, classification here. Okay. So I hope it's correct now. Otherwise, it will crash because it's different model. Okay. So this is what happened. Okay. Okay. Originally, so this one still miskin, 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 miskin. See this one, this miskin becoming sejahtera. The random forest is the algorithm. This one is the predicted value. This one is the predicted value. This is the original value. The classification column is the original value. The random forest column is the predicted value. See, number 14, 15. So 1, 2, 3. Sorry, 1, 2, 3, 4. Change, and then that's it. Yeah. Let me see. Okay, miskin, 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 sejahtera. So 4 change. Okay, we have 4 change by adding 1 0 here. Okay, we can see for family basically shifted from miskin to sejahtera. Yeah. So that's how we play around. So we do the forecasting especially for this kind of thing. Okay, so we can forecast how many person will change if I change the income, if I put 1 0 in the income. So we can see basically out of 37, 4 will change. So how many percentage? I need a calculator. So we have 4 out of 37, 100%. So we have 10% change by adding 1 0 at the end of the income. This is actually the actual. My data is not only for fun. This is not the real data. If you do this in real data, then this number is actually our findings, and these findings can be used for writing a journal paper. That's it. Okay, so this is how to create a journal paper. We have a data, we analyze, we have something that people may not know, and then we publish in journal paper. That's it, as simple as that. I normally, when I write journal paper like this, then I normally include the source code and the what's that, the journal reviewer sometimes they don't really know that I'm actually including the source code. They only think this is the only the workflow, the the mind mapping, something like that. But it's actually the actual program. I put it in the journal paper. So this kind of thing. Okay. Now, okay, I still have around 25 minutes. That's quite a lot. So I can spend some time something more fun. Then. Is there any question? Oh, okay. This is the pin is only Pak Wiranto knows. Someone asked for pin again, Pak Wiranto. So I don't know. Okay, now. Oh yeah, by the way, I'm really hope my recording is working. I'm hoping the recording. If recording working, then I will upload to YouTube. So you are welcome to review the recording because someone is late. I will show this. What? It's sorry. What is? It's sorry. This one. Okay. So I prepare a quiz for you guys. It's in my machine, opencourse.itts.ac.id. Feel free to register, it's free. And then please enroll to ITTS this class. Okay, I will. So this is the class, and then you can do the quiz. You can do the quiz as many times as you like. I will grab the maximum. Uh, so the mark is the maximum mark. Is so you can do as many times as you like. I will remove all the bad marks. I will grab only the maximum mark only. Okay. Okay. How can I see the mark? I will show you, but there is no mark yet. Grades. Skip tour. Okay. Oh, so 1%. Ibu Ai Dianitasari. You already received 65. Okay. Where is the others? The others still zero. Oh, Adian Syah Putra 50, 49 something. So feel free to do the exam as many times as you like and try to aim the as best as possible. If possible, you get 90 and it's okay. Okay, that's it. Uh, no, what's that? No, no time out. No, not barrier. No limitation. You can do the exam as many as you like. Okay. Okay. So I will email the result to you guys every. I will try to email the result of the exam every week then to you guys, so you can see your mark. If your mark is not good enough, then do the exam again. Okay. Okay. Now let me see. What is my here? Okay. So I already showed the clustering, unsupervised learning, hierarchical clustering, misclassification, image analytics, cross-check between manual labelings and hierarchical clustering. I haven't showed the feature ranking. Okay, I will show the feature ranking then now. Let me see. Where is this? Okay. Oops. I hope I'm not closing something more. Okay. Now, to see the feature ranking, we can do some, so we can remove this line. Okay, we can disconnect the program like this. Feature ranking basically, so here we have how many feature? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 features and 1 target classification. Out of 8, which one is the most important feature that will define the classification? That having the ranking, then we can decide which feature we need to emphasize to have a better classification. Okay, so we can do rank like this. Okay, it has several methods for scoring the feature ranking. We have information gain. We can click all of them. Okay, and then we can check using Gemini. What is information gain ratio, and so on. But basically, it gives you some ID. Basically, it will give you some ID which feature is the most important ones. If the feature showed up or many times in in different method, that means this particular feature is important. We can check the best rank, 5 best rank or 4 or 3, depending, because we have only like what, 8 features, that 3 best rank should be okay or enough. Okay, so I connect these two, then we can see here. So in this one, education, income, education. This one, the first education is the type of education. This education, how long is the education? This is the time, how long, how many years. This one, the type, primary school, high school, university, or no education. Okay, so education and income in this particular method. This method, car, this method, okay, car, income and education. Again, we can see income and education. In this method, we can, same as the first one, type of education, income, and how long is the education. The chi-square, car. Okay. The relief, we can see education, car, and this one, motorcycle. This one, income. So most of them is actually income, education, type of education, and how long is the education is. Okay, but sometimes we can see car as the other variable for increasing one status to another status. So, having said that, then we can play around first in the income, second in the education, or how long, or we play around with car. But car is more, maybe car can be used for something productive, I guess. I don't know. Okay, so we can play around with it, with these things. In the real life, we have hundred of features, so we need to select couple, not 3, maybe like 10 feature out of 100. Okay, so we have 100 of feature and we need to select these things like that. Okay, so that's the feature ranking. Okay, For cross validation, I think we have to play around with the example, the easiest one. Okay, let me see if I can. Okay, so oops. Okay, remove this one. Okay, look for example workflow. uh, let me see if I can have cross validation here. Okay, cross validation is basically to see between the confusion matrix and the data itself. So we can select the cell in confusion matrix and we can cross validate in the actual data. Okay, for example, this is what iris table again. Okay, this is iris, and we have logistic regression, we have random forest, we have SVM. We can test these three algorithm here. We can see, wow, okay. Logistic regression is the best. Random forest and SVM is, yeah, quite good, but not as good as logistic regression. Okay. Then from the confusion matrix, we can see in logistic regression we have 5 misclassification, random forest 8, SVM learner 8. Okay, now which one is, oops, sorry. Okay. Which one is the problematic data? We can use this one. For example, in logistic regression, we can select misclassified, then we can see this is the actual data that create problem, and then we can cross check, or we can decide whether we want to remove it, or we can change the value. We can cheat a little bit, or we can remove if you like. Okay, so but the problem by removing these things is actually the model will likely to be overfit, so it's not a good model. I normally will not like to overfit a model, so I would prefer to have some sort of error, so I'm not overfitting the model, otherwise it will not see other values. Okay, so normally I will leave as it is, but uh, I like to see small number of outliers like this. This is sometimes they call it outliers, the one that outside of the main uh, main was that main selection or main values. Okay, so this is the correct one. This is the outliers. Okay. So we have 5 here, we have 8 here, we have 8 here. So I will use this one, it's only 5. Okay, so that's cross validation. Okay, okay. So I have covered all of the unsupervised learning. We have what? Around 15 minutes. That's good. Okay, I will. Uh, I think I will show you a little bit how we translate this program into Python. Okay, so Python will be covered in the here, the last meetings, but I think I will try to show you how to what program this in Python, but not the whole program. But I like to show you. Like to what's it? I like to show you how to basically cheat. So we already have the program in Orange. How can we translate Orange into Python, right? Okay. So basically, the easiest way to cheat, okay, you can use Gemini. Sometimes it will give you quite wow. Okay. 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 Now, uh, some. Let me see the orange stuff. Oops, not this one. I want to show. Okay. Uh, Something simple first. Uh, no, 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 no. Okay. Or maybe like simple. For example, like this. Uh, where is this one? Okay. Uh, Not show. Uh, Give example in Python. Oops. How to read not two, maybe 4 column uh, Excel file containing one target and three feature data. This is on how to read. No, not five column. For example, iris data it has 5 column data, one target and 4 features. That's iris. The example is iris actually. So one single what's that? One single widget like this in orange, we have to write as long as this. Okay, so we have what? How many lines? 1, 2, 3, 4, 5 lines in Python to be able to replace one file, one widget. We need this many lines. Okay, having the lines, then we can having the data read in Python. Then we can again, for example, uh, give example to feed what's that? The above data to the linear regression so we can do something like this, a linear regression. So we get the data from the above, the previous data frame, and we fit like. But we need to be able to here. We have target data, we have feature data. Okay, but we need to change things to make it more correct. This is sometimes not as not correct sometimes, so we have to play around with it and check the correct format and correct syntax or whatever. Okay, so we have to define what kind of model, and then the model is an object, linear regression becoming an object, and we will fit the data using this model. If we want to make a prediction, we can predict the data, but we need to this particular feature data is actually from different data, should be from different data. Then we can do the prediction. The prediction is basically we have the feature data and we will get the target data. Okay, so as simple as that. Okay, and then it can print the error. This is the error. That's it. This is how to what's that? How to translate basically the orange uh, workflow into Python. Why we need Python? If we have to analyze big data, we cannot use it. We cannot use Python to do this. So Python is sorry. If we have big data, we cannot use Orange to analyze big data. So if we have big data, better if we have Python. If we use Python, is better for big data. But we need to be able. We need to have some not instinct. We need to have some what uh, not value. We need to have some basically instinct lah. We need to have some instinct what kind of method we can use to analyze the data. So to test the method, we can use Orange first. Then to analyze big data, we have to translate Orange into Python. Okay. So in real life, we normally use Python, we use Keras, we use TensorFlow if you like. But to test first, I normally use Python. Orange. So Orange, I'm testing. But sometimes if the data is only like what, 1,000 lines in Excel, I sometimes forcing Orange to analyze these things. Still okay. Okay, for 1,000 lines. If we have a lot more data, then we have to switch into Python and Keras. Okay. Now we still have some. Let me see if I can play around with it. Okay. Let me check if there is any more questions. Still about pin, eh? Okay. Well, I cannot answer that questions. Okay. Okay. Now, okay. Let me see if I have. I have. There are a lot of fun stuff here. Okay. Let me see. Okay. New. Okay. I will shift it here. Oops, sorry. Here. Okay. Oops. Remove. Let me play around with our data set. Oh, by the way, the data set provided by Orange is normally limited, small data set. If you want to play around with big data set, one of the good place to play is Kaggle. Oops, sorry. Okay. Kaggle may provide some data set to play around, but I think if we want to publish something from Kaggle, Kaggle has been used for publication, so it's more difficult for us to do publication based on Kaggle data, except if we want to modify the algorithm. Okay, if we do algorithm modification, Kaggle is good because we can compare our algorithm, then compare with the other algorithm use with Kaggle data. But if we want to do some to get some new results, Kaggle can be used for testing, but for the actual publication, better we use our own data. Okay, so we can search for certain data set, and we we can play around with it. The other data set we can use in Indonesia is one data.go.id. The problem with this website, uh, to be honest, in the past, when the team that works in one data is when the team is under the presidential staff, they are good. But right now, this particular activity is under Bapenas. For example, most of the data they have is basically summary. For example, I am looking for miskin. Okay, this is data about miskin. There are a lot of data about miskin here. Okay, we can download. Sometimes we can download. Sometimes. Okay, let me see if I can download here. Okay, let me see if I can download here. Okay, download. This happened a lot. Let me see if I can download here. Okay, preview. Okay, I'll show you the problem with data with the Bapenas. This data actually creating a lot of problem, headache for me, because I cannot analyze. How come? Come on. Psst. Again. This is what happened. Okay. Let me see other thing. Other data. I hope I will get something better. Maybe check for Jakarta or something. Let me see if there is one. Data. Okay. Miskin. Okay. Can I get the data? This is the problem. If we use Kaggle, it will give you the actual data, the file. This is infographics, which is not data. I hate when they did this. Let me see if I can access open data. Okay. 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 Volume data. So it give you the summary basically, the length and width. That's it. So in the data provided by most of the city, most of the government body is normally is like that, the summary. When I said miskin, also the same basically. How many miskin person in this particular city? That's it. When you see the miskin in my data, it's different. See, in my miskin data, I have income, education, house, car. Having this data, then we can analyze. If the data is only in this particular city we have 1,000% miskin. In this particular city we have 2,000% miskin. There is no other data than miskin, then we have problem because we cannot analyze those data. That's already a summary. If the data already summary, we cannot do any analysis from the data. That's the problem with the data collected by Bapenas, by the government. We cannot analyze using that data. So I'm really hope that someone we can tell the person that collecting the data in the government, because having the data, that kind of data, we is difficult for us to analyze. Okay, so we need something more granular, more detail. Otherwise, it's difficult for us to analyze. Okay, but that kind of data is actually available. The one that shared publicly, normally the summary. That's a problem. So we as researcher, as academician, having difficulty to analyze because the data is only the summary. So sometimes I have to beg, I have to go inside the office and beg for data because otherwise they will not give the data. So that's the real life when we do the research. Sometimes we have having problem to grab the data like that. So that's the data set. The other data set that might be interested to many few, is this is my other data set, UNB cybersecurity. I play around with cybersecurity a lot, so sometimes I use this data set from University of New Brunswick in Canada, and they have data. We still do a lot of research on this particular data set. Okay. And then they give away this data set for free, and then we analyze this data. We sometimes developing the algorithm for analyzing this data set. For example, this one. Okay. This one is IDS, Intrusion Detection System, IDS. It's quite a challenge for us. The interesting thing with this kind of data set they have, they actually label the data right now. So they are already labeling the data, so we know that which one is the intrusion, which one is good data. Okay, but the problem is the current problem in the internet. This is about the attack on the internet. The problem with the attack on the internet is the attack is mainly encrypted. Most of the communication on the internet is encrypted. Having encrypted data, we are having difficulty to differentiate between good traffic and bad traffic, because the bad and good are encrypted. We cannot see what is the payload, what is the communication process on the internet, because it's encrypted. So because all of this data is encrypted, then we have to create machine learning AI to analyze this data. Okay. The same problem is happening the National Data Center. A couple of months ago, it's being attacked by ransomware, and we lost many data, because its ransomware is encrypted, and the antivirus cannot detect the encrypted data. So this actually still the major research activity right now today. Okay, because not many software can correctly identify between good and bad on the internet, because all are encrypted. So this is one area that can be used for research. The data is available, but takes a lot of computing time, because the data I download the data is about couple of gigabyte. It's big, huge. It's very big data. couple of for each one of them. Uh, for example, like this, I can click, and then one of them is gigabyte. This is how they generate the data, and it's gigabyte. Okay, but the data is something like this, so it's difficult. What is this? And see this. uh, this is attack. This is DOS. This is spoofing. Okay, that's one thing. Uh, they already published paper out of this. Okay, and then we can download the data set. It's free. We can download, but we need to set we need to submit the request first. Okay, then we can download. Okay, so that's gives you some idea on the data we can play around. We can play around from Kaggle, from One Data, from UNB. There's a lot more data set available, but to play around first, you can use the data set from Orange. Okay, it's 2016 now, so I will go. So next week we will play around with forecasting. Uh, Many of this has been uh, described in my class, so I may play around with other things. Okay. If you have any questions, feel free to email me, and then make sure you do the exam. I will email every week the mark from for the class, so everybody knows what the mark from for everyone. So hopefully that will encourage people to do the exam, to be able to have the highest mark. Okay, thank you very much. I will close the class now and hope to see you next week. Thank you. Okay, I will leave.